So for today we'll cover environments. We left off on Wednesday. We were talking about functions and we talked about scope, right? And so we'll talk about scope again for functions, and then we'll expand on that topic of environments, and then I'll probably take attendance at the end of class or something. So. All right, so I think we said this. We said R has generous scoping rules, and if it, this function is not a good example of a function, okay? It's a bad example because the function, inside the function f, it references a value x and a value y. However, in the arguments, you are only providing the value x, okay? And so you should not do that. Generally, when you run a function, all the values that you need should be given to it in the arguments or defined inside the function, and the function should not have to search for things outside of it. Okay, that's not good practice, but R is very flexible and generous in this regard, and so rather than erroring out and saying I can't do this, it's going to say, okay, you're referencing y. I'm going to search for a y. I found y in the global environment, and it adds the x and the y together. Okay, so in this case, if you pass in the value 3 for x, then the function will take 3. It can't find y. It searches out here, then it finds 1, 3 plus 1, and it returns 4. Okay, over here, we have y defined in the global environment. This one would be, good practice in that, it's a function of x, so we pass the value 3 to it, and inside the function we give the value 2 to y. So we say y is equal to 2, and so thus when it tries to do x plus y, it takes in the value x, which was passed into it as an argument, and then it says, okay, I need a value y, and that is defined for us already inside the function. So it's going to do 3 plus 2, and it returns 5. Yes?
So y is still 1 in the global
y is still 1 in the global environment. This assignment here, 2 being assigned to y, does not affect anything in the global environment. Okay? We have something called a function environment, and we'll talk about that in a moment. Okay? But yes, it is correct to say that if after the fact, after you run this code, g is 3, and you ask what is y, y will still have the value of 1. Okay, so I think this is where I write out the step. So it says, additionally, variables defined within a scope only exist in that scope and for the duration of the scope. So in terms of this function, it only exists when the function is running, and when the function is done running, everything disappears, okay? If variables exist with the same name outside the scope, those are separate and do not interact with the variables inside the scope. So everything's outside of the function, that y equals 1 outside of the function, does not interact with the y equal to 2 or 3, whatever, inside the function. Okay? So you can think of a function as its own separate environment that only communicates with the outside world via the arguments that come in and the output that goes out. Okay? And everything else is kind of enclosed in there. So, for example, if you execute the command remove list equals ls inside a function, which by the way is not a good idea, you would delete all the objects that have been defined inside the function only. You would not be deleting anything outside of the function. Okay, so everything in the global environment is ineffective. However, the exception is with the slightly dangerous superassignment, double arrow operator, which searches a higher scope in the global environment. So the superassignment does interact with a higher environment. Okay, and so I'll show you some examples of that, and it's always a little bit risky showing you this because I feel like I'm giving you a weapon that you're not supposed to be using, okay? So here, we have x, y, and z all defined as 1 inside the global environment, in the global environment. And then we create a function f where we assign the value 2 to y. And then inside f, we create a function g where we assign the value 3 to z. And then g says return the values x plus y plus z. So that's going to be what g returns. And then at the end of f, it says return the value of g. Okay. Well, we already get the answer here. But so what happens when we run this? Okay, when I just run f, okay, it doesn't actually need any arguments here. What happens is it says y is 2, and then it's at the it defines this thing. It doesn't actually execute the g function yet, but it reaches this part, return g. Okay, and so now that it sees, okay, I've got to return this g, it goes back and it says, well, I defined g earlier, and that's this function, and so now I'm going to execute this. Okay, so it says z takes on the value 3, and what I need to do is return the value x plus y plus z. Okay, so it says, okay, I've got the value z is 3. Now I need a value y and x. So it searches the higher scope and it finds y is 2. Okay, and so it says, okay, y is 2, that's my value y. And then it says I also need an x. So it says I don't see an x here inside g. I'm going to search the higher scope. I don't see an x inside the function f. So I'm going to search a higher scope, and I go to the global environment, and I find the value x is 1. So then it's going to do 1 plus 2 plus 3. The function g returns 6. And now that we have a value for g is 6, we can return the value for the function f, and we return the value 6. Does that whole process make sense? Okay. So here again, and we define the function inside f, but g does not exist in the global environment. It only exists inside that function environment, and then as soon as the function's done, that function g is gone. Okay, and then if we go back and we ask what is the value of x, y, and z, we see that everything here has not been affected. Okay, x, y, and z in the global environment is not affected. Okay, here I've got x, y, and z in the global environment. They're all being defined as 1 again. And then now, when I run the function, well, okay, let's actually run this. Okay, so here we're gonna define x, y, and z as the value 1. Okay, and then now I'm going to define the function f. Okay, so I've defined the function f, and I can say what is f? Okay, f is exactly the code that I've written. Oh wait, sorry, it's this right here. Okay, f is this code that I've written here, where we use the super assignment 2. Okay, I have not yet run f. Okay, so I have not yet run f. F has been defined, but it has not yet been run. So if I ask what is the value of y, y is still the value 1. Okay. However, when I execute f, right, I do f parentheses, this is going to execute the code inside the function. When I do that, now we can see that the values y and z have been affected, because here inside f, when we run f, the first thing it does is it runs this code. It says assign the value 2 to y, but use super assignment, so it's going to change the y in the global environment. Okay, we define a g, and then again we say return g, and then so it executes this part. So then when it executes g, then it says assign the value z to 3. The super assignment says don't assign the value 3 to z in this environment, but climb the higher environment, and if you find a z there, change that value to 3. But there's no z inside the function f. Okay, and so it climbs the highest to the higher environment, to the global environment, and it changes the value z to 3 here. and then it adds those two together, it returns 6, and then x, y, and z are now affected, and we have the values 1, 2, and 3. All right, let's look at this here, okay? Something very similar as before. The only difference here is that I've added a line here where I'm assigning the value 2 to y, and then I'm assigning the value 4 to y using the super assignment. Okay? So then, and then we define g, and then we're going to say return g. Okay? And in g, we assign the value 3 to z. Okay, so if I call f, what is it going to return? Is it going to return 6 or is it going to return 8? We're not sure, right? Okay, so let's just kind of look at what happens, right? When I call f, it's going to assign the value 2 to y. And then this assignment is going to assign the value 4 to y, but in the higher scope. Okay? It's going to assign the value 4 to y, but only the y in the higher scope. Okay? Then we run, then it says return g. It's going to execute g here, and it assigns z to the highest scope. And then it says return x plus y plus z. So it's going to search for x. It doesn't find it anywhere. It finds it up here. It's going to search for y, and it'll find this right here. Okay? So when we call f, okay, it's going to run, when it looks for this y, it searches the immediately higher scope. It finds this y is 2, okay? So it doesn't bother with the y that has now been changed to 4 in the global environment, okay? And then it searches for z, and z has been modified in the global environment to 3 here, okay? And so the function returns the value 6, but then if we ask what is x, y, and z, we can see x is 1, y has been changed to 4 because this thing has changed the value in the global environment, and z is now 3. Does that make sense? Okay? Yes?
So if you were to put the super assignment for that y into the g function instead of the f?
Oh, okay. Yes. So here we can do this. Let me just copy this, and we'll. Okay. So if I did this line, and I put this here instead, is that what you're asking?
Yeah.
Okay. So yeah, what would happen here? Okay. So we'll delete everything out. Okay, so this is a good question. Okay, we got x, y, and z. Inside the function, we're going to define y to 2. And then over here, we have super assignment y is 4 and super assignment z is 3, and then return x, y, and z. Okay. So if I execute f, what will it return? So this time, it will return 8, because even though we define y as 2, when we execute this g code, it's going to assign the value 4 to the y in the higher environment here. Okay, so now this thing takes on the value 4. Okay, z gets assigned to 3. It's going to keep searching higher environments, and it's going to change this. Okay, and then so f is going to return 8, and then if I ask what is x, y, and z, what is the value of x, y, and z? It's going to be 1, 1, 3, because this super assignment of 4 to the higher scope is, that mission is completed when it changes the value inside this scope here. Okay, so it doesn't say it climbed the higher scope, it finds the y, it changes its value there, and its mission is done. Okay, and so the y inside the function f gets changed, but there's no need for it to keep climbing higher. All right, so when I execute this, the f is going to return 8, because again, it's going to be 1 plus 4 plus 3, but then we ask what is C, it's going to be 1, 1, 3. Okay? Yeah.
Is there a way to ask like what is y inside the function?
So it depends. Like if you want to ask what is y, you can say print y here, and then you can also ask print y here. Well, actually, this is the same. Oh, you mean after I do return?
After outside the function.
Wait. I'm sorry. Where do you want me to run the print y command?
So like, is there a way to see what y is inside the f function, but printing it not actually in the function?
I don't know if I fully understand what you're asking it to do. You want to know what y is, but when do you want to know what y is?
After the function is run.
After the f function is run? So that's what I'm doing here. I run f, it runs the code here, and then I say what is y, and it tells me y is 1. But that's because it's reporting the y in the global environment. Right. So the hard part about all of this is that we have a y in the global environment, and then we have a y that's defined only in the function f, right? And then we have a y that's named in the function g, but it says I don't want the y in g, I want the y in the higher scope. And because g is defined inside the function f, it climbs the scope and it goes to f, and then it changes the thing there. But the y inside f is different from the y in the global environment, right? Some of you guys are following along. I can look on your faces and you're following along. And then others of you, maybe this is like the most confusing thing I've ever talked about, okay? It's totally normal to feel that way if you are in the confused boat, because this whole scoping thing in R, it's probably, it's very tricky, okay? R has implemented a lot of generous scoping rules so that your code will run even if you haven't defined everything super nicely, okay? But because of that, it also, you need to understand some of the rules. Yes, cool.
So, if I wanted to, so say you do all the assignment here, right?
Yes.
And so y would now be 4, I guess?
So the y inside f or the y in the global environment? The y in the global environment is still 1.
Okay.
It's just this one was changed to f, but because it exists only in the function,
Is there a way that I could ask for, even though it's already defined in the global environment, is there a way that I could see what it is only in that f, like what it's assigned as in f?
Yeah, so we can execute like the debugger, okay? And so let's see. It's a little bit trickier here, but you can create a script with your code, and then you let me save this onto the desktop. Okay, so this will just be example, and then I'm gonna click to the left of the line numbers, okay, and then it'll say breakpoints will be activated when this is sourced. Okay, so we'll source this, and then okay, so now it is running the code inside here. So when you create a breakpoint and then you click source, it runs the code, right? And you can see in the environment over here, normally we have the global environment and we have, here actually, let me stop this. Okay, so I'm gonna just clear everything out in the global environment, and then I've defined a breakpoint right here. And then I'm going to go ahead and source it, okay? So over in the environment, I can see in the global environment I have x, y, and z is 1. And then, now that the code is running and I'm inside of f, I can change the environment that I'm looking at to inside of f, okay? And we can see that here y is 2 before I run this line of code here. And then if I click next, oh well, now it's done. But it has run this. Maybe I'll click create a breakpoint here. Okay. So then I'll go ahead and I'll source this. Okay. Okay. So here I'm inside f. Y is 2. If I click, let's see. Is it continue? Okay. So I click continue, and so now I am inside G. And it has run, and it's pausing right here. And so if I go back to F, we can see Y has now changed to 4. And now I'm inside of G, okay? And I can ask, okay, what is X? X is 1. What is Y? Y is 4. And what is Z? Z is 3. We're inside the function G here. And then I click continue, and it will run. And then it returns the value that we have, I think. Let's see. And then yeah, so we can see that now we have changed it to 1, 1, and 3. And then those temporary environments have disappeared. So there is a way to kind of explore using the browser or setting breakpoints in your source code, and you can change things here. Yeah, question.
So I have a question. So if we simply type like y for an output, is it equal to a print function, or is it a little bit different?
Yeah, the default method that R does is if you call for y, you are effectively asking print y. Okay, so if you just name an object, the default thing that R does is it calls the print command for that object. Yeah. Okay, back to the show here. Okay, so that was a good example. I think let's see. We did something. Yeah, we did something similar here. Okay, so here let me just clear everything out. We define x, y, and z to 1. Here I'm defining this function f, where I assign 2 to y, z is 10, y with the superassignment is 4. And z with the superassignment is 3, okay? So this will change this value from 10 to 3, and this 4 will change the 1 in the global environment, and when I ask for x, y, and z, it's going to add 1, 2, and 3, so we'll get back 6, and then in the global environment, we'll have 1, 1, 1. I'm sorry, it will have 1, 4, 1. So that's what we have there. Okay, so all to say is superassignment is risky, okay, and it can get confusing, and if you use it in your code, it might do things unexpectedly, okay, because a lot of times when you use superassignment, people often think, I'm only going to execute this function from the global environment. So you're thinking you're always modifying things in the global environment. But as you saw, if you execute a function from inside another function, which is a common thing, right? You might have a function, and from within that function, you try to call something else, then things get confusing. And you might be modifying things in the function rather than the original environment or something like that. So a lot of times, you'll have a thing and you're like, I want to modify something in the global environment, and you're tempted to use the superassignment. I really advise against this. So you might be like, I want to change X, Y, and Z in the global environment to something else. This is one way to do it, and you can. X is originally 1, 1, 1, X, Y, and Z are originally 1, 1, 1. You run the bad code, and now X is 2, 4, and 5, okay? That's not the best way to do it, okay? A much better way is to define X, Y, and Z. Inside your function, you are only using regular assignment operators, but then at the end, you return an entire, the list of all the values you want. Okay, so here I'm saying I'm returning a list where X is X, Y is Y, and Z is Z. Okay, and this time, instead of just calling the command, as like a naked command, I am taking the output of the function. I'm taking the output of the function and I'm storing them as results. Okay, so when I run the code this way, I'm defining x, y, and z. I define the function here, and then I'm going to capture the output of the function into this list results. Okay, and then so if I ask maybe I should just use print, but if I ask what is the value of x, y, and z, it's 1, 1, 1. Okay, and then if I want to change these values, then within the environment that I'm in, inside the global environment, I redefine x to be the results value x, the result, and I redefine y, and I redefine z. And I say, okay, we're going to assign x to x, y to y, and z to z, and then those values change, and now we have kind of the results that I want, 2, 4, and 5. Okay, and although this is, yes, it is a few more lines of typing. Okay, however, in your code, if something goes wrong, it's very clear when the change to the value has happened. Okay, you see this line, you know exactly it is this line where you said I'm changing the value of y to something else. Okay, if you have it happening inside another function, okay, imagine you're reading your code. This is where the change has happened. It's happened inside this execution. Okay, it doesn't happen in the defining of the function, it happens in the execution of the function. Okay, and so unless you have memorized every single part of your code, you might not realize that it is at this moment when this line is run that the values x, y, and z in the global environment have changed. Okay, and it makes it a lot harder to try to track down where a mistake has happened if you don't explicitly change the values. So it's much better to do your explicit assignment. So I know someone on Piazza asked the question, I want to update the state and things like that. Technically, yes, you can update the state using super assignment within the function. That is technically possible, but again, not a good idea. It's best to run the update thing, have the update state function return a new state that you then reassign to the state that you're using. Okay, so because this way it's very clear when the changes have happened, and no changes are happening when the function itself is being run. Okay, and again, and if you call a function from inside another function, maybe you don't get the results that you're expecting. All right, is that okay? Okay, so we'll continue on here. Okay, so the goal of a function should be to encapsulate a small reusable piece of code. It should make clear what the function does. Okay, so yeah, so functions make things modular, and then if you need to modify things, you can just modify one chunk of the function. Okay, the code in one location, then copying and pasting the command everywhere. Okay, is that all right with functions? Okay, so now I'll just define environments a little bit more thoroughly. Okay, so the environment is the data structure that allows us to do scoping, and the job of the environment is to bind a set of names to a set of values. Okay, so the environment is pretty much a bag of names. Oh, you know what? I'm gonna have to upload these pictures into a little directory onto CCLE. Sorry, you don't have your pictures in here. Okay, so the environment is a bag of names, and then when you create assignments, okay, so here we're defining E as a new environment, and we're saying we're going to bind the value false to the name A, we'll bind the value character A to the name B, and so on and so forth. Okay, that's what we are doing. Okay, a lot of times if we don't have $A, we're inside the global environment, but it's the exact same picture. It's just R is using the global environment rather than a new specific environment. Okay. Every environment has a parent, which is another environment. Okay. And in diagrams, the pointer to a parent will be this little black circle here. And the parent is what is used for lexical scoping. Okay. So if a name is not found in the current environment, then R will climb to the parent environment and search for the name there, okay? And every environment has a parent until you get to the very last environment, which is the empty environment, and that's the grandparent of all environments. Okay. So the global environment, this is your interactive workspace, okay? It's the one where you normally work, and the parent of the global environment is the last package that you've loaded. Okay, so if you loaded any libraries, the last one you've loaded is the parent of the global environment. Okay, the base environment is the environment of the base package, and the parent of the base environment is the empty environment. Okay, the empty environment is the ultimate ancestor of all environments. It's the only one without a parent. Okay, and then environment, this is the function you call to ask what is the current environment. Okay, most of the time, its answer will be global environment. So if I say, if I ask R right now, what is my environment? Okay, it's going to tell you you're in the global environment. Okay, search. This is the search path, and it lists all of the environments that you've loaded. So if I say search, okay, it's going to say, right now you're in the global environment, but its parent is Tools R Studio, and its parent is package stats, and its parent all the way up to package base. Okay, this is kind of the highest, and then after that will be the empty environment. So if we're talking about the search path, this is what it looks like. So the global environment, it climbs up the search path in terms of all of the different packages or libraries that you've loaded, okay? And when you start up R, it loads all of these kind of libraries or utilities, these different packages just automatically. These are kind of the default ones. And then if you say, like, I want to load library ggplot2 or something like that, and then I ask what is the search path, now we can see the global environment is where I am, and its parent is ggplot2, and that parent is going to be the RStudio. Okay, so this kind of just defines how the search path goes. As far as here, we're in this environment, and if I don't find it, I'm going to climb up and up and up. So yeah, so anytime you do library, it's going to insert itself between the global environment and then the last one. So if I call library dplyr, okay, and I ask for search, then we have that. So it just inserts itself right after, right above the global environment. Okay. The most common time we have to worry about function environments is when we are dealing with functions. Okay, so a function will have 4 environments. Some are the same, that are either the enclosing environment, binding environment, execution environment, and the calling environment. Okay, the enclosing environment is the environment where the function was created. Okay, and every function will only have one enclosing environment. Then the binding environment is the environment where we have kind of defined the name. Okay, binding a function to a name defines a binding environment. So this is where the function is tied to a name. When you execute a function, it creates the execution environment. This is the environment that exists only during the running of the function, and it has its own kind of set of variables and whatever. And then as soon as the function is finished running, that execution environment disappears. And then lastly, that execution environment is associated with a calling environment, which will tell you from where the function was called. Was the function called from inside another function? Was it called from the global environment? Wherever that function was called, wherever that command was written to say run this function, that's the calling environment. Okay, so when we create a function, it gains a reference to the environment where it was made. This is the enclosing environment. And when you name the function, the environment where the name exists is the binding environment. Okay, and in most situations, the binding environment and enclosing environment is the same. All right, so here I'm defining the value 1 inside the global environment, so y is bound to the value 1. And then I'm creating a function f. Okay, f is a environment and is a function, and if we ask what is the environment of f, okay, here it's going to tell me that it was created in the global environment, so thus the enclosing environment of the function f is the global environment. The binding environment is also the global environment because that's where the name f exists. So f is created in the global environment, so that's the enclosing environment, and because the name f exists in the global environment, it is also the binding environment. Enclosing and binding environments, the difference is when we're dealing with package namespaces, okay? Oftentimes when we run a package or something, the function was created in that package environment, and where does the name exist that exists in a namespace? Generally, this is probably the most important line of the slide, is you don't have to worry about this stuff as far as the difference between enclosing and binding environments for package namespaces, okay? Unless you're starting to write your own packages for R, which is not what we're gonna do in our class here, okay? When you define a function yourself in your code and in your script, you can expect the enclosing environment and the binding environment to be the same, okay? It's only when you're kind of defining defining functions in packages that get loaded via libraries. Okay, but yeah, basically, if you create a package with its own mean function, it keeps it separate from the mean function in the base type of thing. All right. So the execution environment, we kind of saw this already. This is the new environment that is created just to handle the execution of a function. So when the function is running, the execution environment comes to life, and then after the function is finished, the execution environment disappears. Okay? So here we have h, the function h. Inside this environment, we're going to say a is 2, and then we add x and a together. Okay. So what does this look like? We call the function h with the value x1. Okay, so when we do this, okay, h exists in the global environment, and we're executing h, passing the argument 1. So when we do this, 1 gets associated with the value x inside the execution environment. Okay, and in the first line of code, we're going to take the value 2 and assign it to a. That happens inside the function, and so that's why in the global environment, we're not creating variables x and a, yet inside the function, we can reference the values x and a because they exist inside our execution environment. So when the function runs, it says, okay, here was x and a. We're going to add those two together and we get the 3. And so at the end, when the function is run, it returns that value and it binds that value to the value y inside the global environment. So in the global environment, 3 gets bound to the value y, or the name y. Okay? X and a, they are defined in the function and exist only in that execution environment. When the function is done running, that execution environment disappears. There's no trace left of x and a. and just the result is now associated with the name y. Okay, there's a calling environment. That's if you're calling a function from inside another function, that's going to define the calling environment. We will not worry too much about the calling environment. I think the most important part is understanding the execution environment and the enclosing environment. Okay, are there any questions on this? Okay, let me, I'm going to take attendance then. We'll take attendance at the end of class today and then change it up, right?